Okay, thank you. Today we are going to learn mole. You know, mole is a chemistry concept which is very important, and it deals majorly mathematics, and this topic is very important for the students. So we are going to start defining mole. So mole can be defined in two ways. Definition number one is a number of particles contained in Avogadro's constant. That's the meaning of mole. So Avogadro's constant is a value which is shortened as 6.023 times 10 power 23. This is 23. This is 23 is power. It's not a value, it's a power. You can also define mole as a counting unit, but this definition is very weak, so this is the most common definition. Define mole, if you are told, you say number of particles contained in Avogadro's constant. So in this mole, it involves majorly calculation. Unit calculation. It involves majorly calculation. So let us now see calculation about mole. Especially we are going to see how to calculate relative atomic mass, RAM. So relative atomic mass, RAM, relative atomic mass. So this relative atomic mass is not the one for the computer, which is random access memory, not that one. This one is shortened from relative atomic mass, and this one you have learned in where? Form 2. Now let us see this example number 1. Example number 1 says chlorine 35 exists in the atmosphere with a percentage abundance of 75, while chlorine 37 contains 25%. Calculate the relative atomic mass of chlorine. So you know, chlorine is it has an isotope. An isotope has different mass. It has 37, a mass of 37, and also a mass of 37 and a mass of a mass of 35 and a mass of 37. Why does chlorine has different mass? You know this one you have learned in Form 2, because chlorine is an isotope. An isotope is any substance, or isotope is these are elements that have different mass number but same atomic number due to the number of neutrons. Due to the number of neutrons in the atomic in the structure of the atom, in the nuclear, so chlorine will have different mass, 35 and 37. Again, the percentage abundance of 35 chlorine is 75, and the percentage abundance of 37 chlorine mass is 25. So we are told to calculate the relative atomic mass. For you to calculate the relative atomic mass, this is the formula that you use. The formula that you use is you multiply the individual mass with its individual percentage, and this one the individual mass with its individual percentage, then you sum up, then you divide 100. That's the general formula. Let's write it. Relative atomic mass is equal to 35 chlorine times its percentage is 75. Then we close bracket, we open bracket, we close bracket. Then we say plus. Then we go to chlorine 37 times its percentage abundance, which is 25. Then we close and we open bracket, we close, then divide by 100 all of them. So this is the general formula of relative atomic mass. So 35 times 75, when you multiply them, you will get, if I'm not wrong, 6,000. Let me confirm from the calculator, because this one we cannot do overhead. 26,625 plus, then when we multiply 37 and 25, we get 925. Then all over 100. Don't forget this 100. Children mostly they forget. So when you sum up this, you sum up the top part, 2,625 plus 925, you will get 3,550. 3,550, then you divide 100. Then 0 goes to 0. Then 355 divided by 10. Then you get it 35.5. 35.5. So this 35.5, it's not minus, it's a decimal figure, it's not a minus, it's a dot. Okay, 35.5 is the relative atomic mass. Always the relative atomic mass value is always closer with the mass that have the highest percentage. So chlorine 35 and chlorine 37, which one has the highest percentage? Chlorine 35 has the highest percentage, you see? And its mass always is 35, which is closer to the relative atomic mass. That's where you can also get the leakage. Okay, thank you.